Hello, welcome to Chapter 10, Section 3. And this chapter is on chords. And if you remember what a chord is, it's the segment that goes through a circle, touching the circle in two spots, ending on the circle. Chapter 10, Section 3 starts with Theorem 10.3, and it says, in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So what am I talking about? If these chords are the same, for example, BA and BC, then arc BA has to be the same measure as BC. So BA would be congruent to CD. So let's look at an example of a problem. So if I take this problem and I tell you that AB is 110, you should in theory be able to find BC and AC. And one thing you want to remember is BC, which is only two letters, is obviously referring to this minor arc instead of this major arc because it has two letters. So since chord AB and chord BC are the same, this has to be 110 degrees. Obviously, we could figure out the rest of AC if we needed to. So if you look at this next one, AC is 150, so 150 goes here, from here to here. And I know that these two would be the same, so I'm going to take 360 minus 150, get 210, and I'm going to divide that by 2 and get 105. Okay, let's look at our next theorem, which is 10.4, which is also accumulation of 10.5 too, which I didn't have, but they have the same idea. So if I look at this and it says, if a radius and diameter is perpendicular to a chord, are bisected. So if this chord coming through here is perpendicular to this line, then these have to be bisected. So then obviously FH would be 7 and GD would be 40 degrees. Theorem 10.5 just says that if a segment is bisected and perpendicular, then obviously EG would be a diameter or a radius. So let's look at an example. The radius of the circle is 13, QL is 5, find HL or HK. Hopefully you realize that if I find HL, then I know HK is just double HL. One thing you want to realize is QJ is a radius. And a lot of people think, okay, that's 13, QL is 5, that allows me to find this is 8, and then you're done with the radius. But if I'm trying to find this value or this value, since they're the same, you have to realize you have to be able to draw another radius in. And that radius would be 13, or I could draw it over here, doesn't matter, and that's 13. So please be reminded that you can put a radius anywhere you need to. And once I have that set up, then it's Pythagorean theorem using 13 squared, x squared, and 5 squared. So I get 169 equals x squared plus 25. I get 144 equals x squared, and x is 12. And then just remember, if that was 12, that this would be 12 and HK would be 24. Okay. Sorry, I didn't mean for that to print. Theorem 10.6 says this. In the same circle or congruent circle, two chords are congruent if and only if they are equidistant from the center. So right here, AB would be congruent to CD as long as EF is the same as EG. How do I know they're equidistant? I would tell you, but then you know that they're perpendicular to the line as well. So an example of what I could ask looks like this. I tell you that AB is 12, I tell you DC is 12. That tells me that I can then set 7x minus 8 equal to 3x, and negative 8 equals negative 4, and x is 2. In this one, just be careful. In this one, I tell you this is 22, but I only give you this piece here. But obviously, they are equidistant from each other. They're perpendicular, so I can do 2 times this would equal 22. And x equals 3. And that would be what we wanted to find. I did realize it asked for EF in this problem, which obviously would be 6. The next 2 problems are a combination of any of the theorems you use. So why don't you pause the video and take a second and see if you can do this one. And then we'll go over the last 3 problems when you're done. So hopefully you paused and didn't go on, but one thing I'm going to do is draw that this is a radius too, or that this is a radius. And I wanted you to realize that this is 9. So if this is 12, okay, we can be able to come back and figure out what this is after I find this piece. I know this is 90, I know this is 12. So I can do 12 squared equals 9 squared plus x squared. I can take 144 minus 81. Which is 63, and I get the square root of 63, which is 7.9. Once I call this 7.9, I know this had to be 12 because that's a radius. 12 minus 7.9 is 4.1, so x equals 4.1 in this case. And the last 3 I asked you, do you have enough information to determine AB a diameter? And obviously the things we want to focus on, is it perpendicular and is it bisected? Because it can be perpendicular, but if it's not bisected, then that's obviously not a diameter. It's not running through the center of the circle. So obviously if you look at A, we have justification that it's perpendicular and we have justification that it's bisected. So yes, AB's a diameter. B I'm going to skip because it's a little harder, but let's look at C. AB is going down, it's perpendicular, that's great. But this is 3 and I don't have a value here, but I can use Pythagorean theorem, which is our famous 3 blank 5 triangle. So it'll be 9 minus 25, it'll be x squared equals 16 and x equals 4. X equals 4. So because it's not bisected, this is not a diameter. And then let's look at this one. They're giving us enough information that I can mark this congruent, and now I know that these 2 triangles are congruent. Well, if the triangles are congruent, then obviously this segment would be congruent to that segment. So that totally shows me enough that it's bisected. The justification for the perpendicular comes from CD is a straight line, and if this is going through that line and it has to be congruent, then yes, these are both 90 degrees. So this is bisected and it's 90 degrees, so AB is a diameter. All right. All right. Thank you. Hopefully you can complete the worksheets at task on chords.